Hey everyone! So if you're getting ready to take your PCI Level 1 or Level 2 certification, you are in exactly the right spot. We're going to use this explainer as a super focused study guide to really nail one of the most important and definitely most testable topics out there, concrete curing. All right, let's get into it.
I want you to think of this as the main event. This is the central question of your entire exam, really. Pretty much every rule, every number, every little detail we're about to cover, it all comes back to this one thing. If you can get this, you are going to be in fantastic shape. So what's the answer? Well, let's find out.
Okay, before we start throwing a bunch of numbers at you that you have to memorize, we've got to start with the why. Trust me on this. If you understand the basic science behind it, it makes it so much easier to remember all the rules when you're under pressure in that exam.
And here it is, hydration. That's the answer to that big question. This one word is the whole ball game. It's that magical chemical reaction that happens when cement and water get together. It's what gives concrete all of its power. Every single rule about curing is just about one thing, protecting this process. That's it.
Think of this as two forks in the road for your concrete. Over on the left, you've got the bad path, premature drying. That's where you lose moisture way too fast or the temperature is all over the place. And the result? Plastic shrinkage cracking. You're going to want to circle that term in your notes. Now, on the right, that's the good path. With proper curing, you get to keep that moisture, keep a steady temperature, and the result is exactly what we want, strength and durability.
All right, this is where you really need to focus. Get ready to take a screenshot or grab a pen, because this next part is all about the specific numbers you absolutely have to know. These aren't just suggestions, these are prime questions for your exam.
First up, 50 degrees Fahrenheit, or 10 degrees Celsius. This is your floor. It's the absolute, non-negotiable minimum temperature. Your concrete has to stay at or above this temperature for the entire curing period until it hits stripping strength. No ifs, ands, or buts.
And on the other end, we have the ceiling, 158 degrees Fahrenheit or 70 degrees Celsius. Now you might be thinking, hey, wouldn't hotter be better? Get it done faster? Nope. Going above this temperature can actually cause some serious long-term damage inside the concrete. So that's your window. Stay between 50 and 158. Now let's talk about strength. For non-pre-stressed units, you need at least 2,000 psi before you can even think about stripping the forms. For pre-stressed, that number jumps up to 3,500 psi. But here's the catch, and this is a big one. These are the absolute minimums. Always check the production drawings because they will very often call for even higher strengths.
Okay, so we've got our temperature targets and we've got our strength targets, but how do we actually prove the concrete is strong enough? I mean, you can't just look at it and guess, right? This part is critical for PCI, so let's look at how we verify the strength.
You're going to hear a ton about maturity methods. Basically, they use a formula with time and temperature data to predict the concrete strength. Think of it like a really smart weather forecast for concrete. It's an awesome tool for figuring out when you're getting close to your target. But notice the key word I keep using there, predict.
And here it is. This is the big gotcha that shows up on exams all the time. I can almost guarantee you'll see this. A maturity meter can give you a great prediction, a great forecast, but it can never, and I mean never, be the only reason you decide to strip a form or transfer stress. It's a guide, not the final verdict.
So if maturity isn't the final verdict, what is? This is. It's the physical test. You have to break test specimens, cylinders or cubes, that have been cured under the exact same conditions as the actual piece you're making. They have to be like a little brother tagging along and experiencing the exact same heat, the same moisture, everything. That is the only acceptable proof of strength.
Okay, let's switch gears a little and move from the books to the plant floor. As a certified tech, a huge part of your job is monitoring this whole process. You need to know what you're looking for and, more importantly, what red flags to watch out for.
You can't just stick a thermometer anywhere and call it a day. Where you put your sensors is a really big deal. You've got to think about where the heat is coming from, how the form is built, and especially the shape of the concrete piece itself. For example, a thin little flange is going to heat up and cool down way faster than a big, thick web. You have to know what's going on in all the different parts.
And that leads us to probably the biggest red flag of all. The absolute worst thing you can do is let one part of a concrete element cure at a different rate than another part. When that happens, you're basically creating an internal tug of war. One part is shrinking and pulling this way, while another part is pulling that way. And concrete is terrible at tug of war. It cracks. Uniformity is everything. All right, let's bring it all home. We've gone through the science, the numbers, the procedures. Now let's do a quick, rapid-fire review of the absolute key takeaways you need to have locked and loaded for your exam.
Okay, screenshot this, write it down, do whatever you need to do, because this slide is the test boiled down. 1. The whole point of everything is to protect hydration. 2. Your magic temperature window is 50 to 158 Fahrenheit. 3. Know your minimums, 2000 psi for non-pre-stressed, 3500 for pre-stressed. And 4. The real proof is always from breaking test specimens. Maturity is just a prediction. Got it?
So, I'll leave you with this one last thought, a question to ask yourself right now. Why is it so completely non-negotiable that test specimens have to be cured under the exact same conditions as the product? If you can answer the why behind that rule, not just repeat it, then you truly understand this material. You've got this. Good luck. Now go ace that exam.